Let's start with the first example of a proportional relationship between two quantities, the amount of strawberries and the corresponding price. So, if we have to pay £3 for one pennet, then of course we'll pay £6 for 2 pennets and £9 for 3. We say that the price of strawberries is proportional to the number of pennets. For our second example, let's look at this table indicating the mass of fat in a given food for different masses of this food. So, we see that for 100 grams there are 20 grams of fat. For 50 grams of this food, that is half of 100, we have 10 grams of fat, which is indeed half of 20 grams. And for 20 grams of this food, we have 4 grams of fat, which is indeed 1/5 of 20 grams. That is 20 divided by 5. So for these three pairs of values, we see that the proportion of fat in this food is 20%. We say that the fat mass in the food is proportional to the food mass. Another example with food is the following recipes. The first is for 2 people, the second for 4 and the third for 6. We notice that the second is equivalent to the first, but with all ingredients multiplied by 2. And in the third, all ingredients have been multiplied by 3. This means that the quantity of each ingredient is proportional to the number of people the recipe is for. And as these diagrams show, we see that the different recipes give different sizes of the cake, but the composition of the cake remains the same because the proportions of the different ingredients in each cake are the same. We say that the ingredients in all recipes are in the same proportions. And our last example is the floor plan of a flat drawn to scale. It is indicated here what length on the plan represents a length of 1 meter in reality. If it is, for instance, 2 centimeters, this means that all lengths measured in the flat have been divided by 50 to give the length on the plan. We say that the actual measurements are proportional to the lengths on the plan.